This is GATE 2015 question number 29, which states that, it's a numerical answer type question, which states that a beam of X-ray of intensity I0 is incident normally on a metal sheet of thickness 2 mm. The intensity of the transmitted beam through that sheet, obviously, is 0.025 I0. The linear absorption coefficient of the metal sheet in meters inverse is what? Up to 1 decimal places we have to give the answer. So if I come to the solution, so suppose this is the metal sheet which is given here of thickness 2 into 10 to the power minus 3 meters or 2 millimeters. I0 is the initial X-ray intensity normal to the metal sheet, and IT is the transmitted intensity, which is given in the question to be about 0.025 I0. Now what happens is that the amount of intensity change which happens when the X-ray is passed through this metal sheet is Di. Suppose the change in intensity is Di. So Di to that of the original intensity is actually some alpha times dx. Fine, with some negative sign. This is what is the actual thing, or we can see that the intensity decrease with x, the intensity decrease with x is actually minus alpha times I. Therefore di by, we can write now this di by I is alpha dx, and if we integrate it becomes log of I by some I0, the initial one, is minus alpha times x. Therefore I becomes, if we take the exponential on the other side, becomes I0 e to the power minus alpha x. This is how we can calculate from the metal sheet any kind of EM waves when it is traveled through some kind of a metal sheet or some kind of absorbing material, with alpha is the absorption coefficient, then this is how the intensity varies. And we will use this particular expression that we know that the intensity of the X-ray absorption or any EM wave absorption takes place like this. The transmitted intensity is initial intensity times exponentially to the power minus alpha x, where alpha is the linear absorption coefficient. Fine. Now IT by I0 from here is e to the power minus alpha x, and we know that the IT intensity transmitted through the metal sheet is 0.025 of the initial intensity I0. It is given. So given that IT is nothing but 0.025 I0. Right. So this is given. So I have just written it. I0 is there in the denominator. I0 cancels. We get 0.025 is equal to e to the power minus alpha x. Take natural logarithm both sides. A log of exponential is nothing but this power which will come here. Log of 0.025 comes out to be minus 3.6888. That is equal to minus alpha x. Minus cancels. Alpha comes out to be 3.6888 divided by 2 into 10 to the power minus 3, because x is equal to 2 millimeters and alpha comes out to be 1844.4. Therefore the answer of the linear absorption coefficient when an X-ray is passed through this metal sheet is about 1844. So if you come to this particular solution, it comes out to be 1844.4. So this is the answer. Thank you.